Alright, so this is the solution for Frappy number 4. It says arsenic is a naturally occurring chemical that can enter groundwater through eroding granite and from a burned forest. And health organization recommends drinking water should contain no more than 10 parts per billion of arsenic. A company produces filters to clean arsenic from private wells that could be affected by the groundwater. The company wants to investigate the effectiveness of a new filter compared to that of an old filter. They will test the filters on a field that is bordered on one side by a granite ledge and on the other side by a burned forest. The field is divided into 8 square plots of equal size, and a well to collect groundwater is drilled to the center of each plot. One filter will be used in each well. The following diagram shows the placement of the wells in the field. The company will use 4 of each type of filter to conduct the investigation. A randomized block design will be used. Okay. So part A, assuming that there is a difference in the effectiveness of the 2 filters, under what conditions will a randomized block design be better in detecting the difference than a completely just randomized design? Alright, so rather than just doing so if we just think about this for a second, what would be the advantage of doing a randomized block rather than just randomized? Well, if it's just strictly randomized, we could end up with, let's say, all 4 of these are the new wells, or use the new filter, all 4 of these use the old filter. But the problem with that is we've got different things. We've got the burned forest and the granite ledge in there. And that can cause, so it wouldn't give us a really good idea about how everything's going. We need to be able to compare similar things. And that's the key about this. We need to be able to find a comparison using some similar aspects. Alright. So because of the fact all 4 of these wells, 5, 6, 7, and 8 are all along the burned forest, and 1, 2, 3, and 4 is by the granite ledge. So if we have those based upon and set as a block, that's going to help because they have something in common. They have where they're located. Alright? Which could mean that they have similar arsenic levels. Alright, so let's write this up. A randomized block design would be better in detecting a difference in the filters than a completely randomized design, because there is an aspect of half of the wells. Oh, I spelled half twice. That has a similar location so granite ledge or burned forest. which would the similar locations would have similar arsenic levels, concentration levels, we'll say that because it's talking about concentration levels. Okay, all right, that's part A. Part B. Identify the wells by number that would be included in each block. So, kind of already talked about it. We're going to look at the ones next to the granite ledge as one block, and the ones next to the burn forest as one block. So, the wells closest to the granite ledge wells 1, 2, 3, and 4. We have to name them. Should be one block. The second block would be the wells closest to the burn forest. And this would be wells 5, 6, 7, 8. Okay. And that's all we have. We have to just identify the wells, and by number that would be included in each block, and we did. Describe how to assign filters to wells to create a randomized block design. All right, so it told us that we have two filters. We have the old filter and the new filter. We're going to use equal amounts. So for the first block, we need to have two of them have old filters and 2 of them have new filters. So a couple ways we could do it. So if we want it completely randomized, we want to then possibly pull slips of paper out of a hat. If by flipping a coin, one thing you might be thinking about is maybe, okay, I'll have half odd. The odds will get this one, the evens. That's not necessarily completely randomized. It is a randomized way of doing it, but it's not completely randomized. So the slips of paper is probably the better route to go. So the new filter, and remember, you need to be able to explain this enough so that if this was given to somebody, they could run this experiment. And the old filter will be assigned to the same number or same amount of wells. Let's put it that way. Okay, so this indicates that we're going to have equal ones for the first block. All right. Write on slips of paper wells 1, well 2, well 3, and well 4. Place the slips in a hat. And mix around. You might be wondering, why are we going to do that? Just so you know they're all jumbled up. You need to indicate some way that they're just not laying in there, so it makes it more random. And mixing the slips. Now this next part, you could say every other one that is drawn is odd, is the old filter and the new filter, or you could say the first two drawn are the old filters, first two drawn are the new filters, whatever. There's lots of different ways you can go from here, as long as you fully explain it. So let's say the first two slips and again without replacement. We're not going to put them back in the back in the hat. We'll get the new filter. And the remaining wells we'll get the old filter. Okay. So that's the first block. Now we need to do the second block. And so for the second block, it's pretty easy. All we have to do is we can repeat this process for the wells 5, 6, 7, and 8 to determine which filter is assigned. For the second block, the process will be repeated. For wells 5, 6, 7, and 8 to determine which filter is assigned to which well. Alright. That's it. This was just a quick review about experimental design. If you have any questions, please talk to me.